What's up, Harriton? So today we're going to be looking at 10.6 and we're going to be figuring out more information that we can glean based on the location of angles and the arcs that they open up to on some circles. Let's get started. Check this out with one another in class today, and I'm going to ask you guys to find angles 1, angles 2, angles 3, and angle 4. But what we're given so far is the measurement of arc AB is 46 degrees. And the measurement of arc CD is 53 degrees. So that's what I'm going to write down. That's the information I know. This is arc AB, 46 degrees. Arc DC is 53 degrees. Let's check out how can we find measure of angle 1. Well, that angle is opening up to this arc. And what do I know from the previous section about inscribed angles? They equal half of its intercepted arc. So angle 1 is going to be 1/2 of 53, and the answer I get for that is 26.5. Perfect. Angle 2, let's check this one out. It's also an inscribed angle, and it also opens up to arc DC. So same thing for angle 2. Angle 2 is going to be 1/2 of its intercepted arc, and I'm going to get 26.5 as well. Next thing I'd like you guys to find is angle 3. And angle 3 is over here, and it opens up to arc AB, which is 46 degrees. Half of 46 is 23. And angle 4 is over here, and it also opens up to arc AB, and since it's an inscribed angle, I know it's half of its intercepted arc, and I get 23. Awesome, great review from yesterday. Moving on. If two inscribed angles or tangent chord angles intercept the same arcs, then they are what? In other words, from our previous example, angle 1 and angle 2 both open up to arc DC. If they both open up to arc DC, I know that angle 1 is congruent to angle 2. Therefore, I'm going to say these two angles are congruent because they open up to the same arc. In other words, I'm going to say angle 1 is congruent to angle 2. And I'm going to take that even further and say angle 3 is congruent to angle 4 because they both open up to arc AB. This will come in handy, you'll see. Let's investigate this one together. An angle inscribed in a semicircle is what? In other words, I have angle P. It's inscribed because my vertex is on the circle, and it opens up to a diameter DE. And I'm asking you, what is that measure of angle P? Well, since DE is a diameter, I know that arc DE must be 180 degrees. And since 180 degrees is the arc that's intercepted by angle P must be 90 degrees. So basically, an angle inscribed in a semicircle is a right angle. And I know its measure is 90 degrees. That'll come in handy. So there's this cool theorem here in our book, and it's called the two-tangent arc angle theorem, and this is what it does. I'll show you how it works in just a minute. But this says the sum of the measures of a tangent-tangent angle. My angle out here, angle P, is what we're calling the tangent-tangent angle because it's made by two tangents. So it's saying the sum of this angle and its minor arc, the smaller one, is supposed to be, and always will be, 180 degrees. This fast-getting piece of information is going to come in really handy throughout the rest of this chapter. I'll show you why this works, though. Given that this arc is 100 degrees, I know the major arc is 260 degrees. And from what we learned about this angle here yesterday, it being an external angle, I know that angle P should equal 260 minus 100 divided by 2. And the answer I would get, after I keep simplifying, is 80 degrees. So are there two ways to find angle P? Absolutely. Yesterday, we subtracted the major arc from the minor arc and divided by 2. And today, I'm introducing a theorem to you guys that says the sum of the external angle and its minor arc is 180 degrees. In other words, they're supplementary to each other. Let's put that theorem to good use now. Given PQ and PR are tangents, okay? And I also know that QR is 163 degrees. They're asking me to find the measure of angle P and find the measure of angle PQR. Now if I check out angle P here, I realize that it's a tangent-tangent angle, and I know that its intercepted arc and that angle are supplementary. So to find angle P, I'm going to say angle P plus 163 must add up to 180. I subtract 163 from both sides, and I figured out angle P is 17 degrees, all from that theorem that I just learned on the previous slide. And now it's asking me to find angle PQR, this angle over here. Now there's several ways to find it, but I think the quickest one is I discover that it's an inscribed angle, and I know an inscribed angle is half of its half of its intercepted arc, and so I know that angle PQR should equal half of 163 degrees. And after I solve that, I get 81.5. I'll show you another way to find that in class. It takes longer though. Alrighty family, let's put all this information to good use and wrap this thing up. Arc WZ I'm given is 126 degrees. Arc XY I'm given is 40 degrees. They're asking me to find the measure of arc PQ, which is on the smaller circle. Let's figure out what I know. So I'm going to be checking out this little angle over here. You see that little guy? Okay, it's an external angle, and I see that it opens up to 126 and to 40. And to find that from yesterday's lesson, I need to find their difference and divide it by 2. So this fun little angle here is going to equal 126 minus 40 degrees divided by 2. Once I solve for that, I see that it's 43 degrees. Now, if this is 43 degrees, I also know that its vertical angle must be 43 degrees. So if I have 43 degrees here, and I see it's going to open up to the intercepted arc that I'm going to find the answer of in just a short moment. Now, what I just learned on the previous slide from a cool theorem in this chapter, or in this section, it says that arc PQ and 43 degrees must be supplementary. Subtract 43 from both sides, and I solve for arc PQ, and it is 127 degrees. Excellent job, Harriton. Your homework is on the next slide, and we'll see you in class soon.